All right, this is a review of graphing rational functions, and the section 8.2 was a little more simple simply because everything was the nice hyperbola branches and the graphs didn't get too complex. So just a quick refresher of everything. To find vertical asymptotes, you always solve the denominator because your denominator can't equal 0, so that's where an asymptote will occur. So if I set my denominator equal to 0, I'll add 1, and obviously x equals 1 will be my vertical asymptote, and I would recommend drawing in those asymptotes, and I'll talk about why in a second. Your end behavior asymptote, of course, depends on your degrees. So if the degree on top, which is technically 0, is less than that of the bottom, which is x to the first, then y equals 0 will always be your end behavior asymptote, and that would be, of course, the x-axis. X-intercepts, you solve the numerator, because if you put 0 in for y, it always will end up that when you multiply this denominator over times 0, it always wipes out. So you always end up solving the numerator. While 0 equaling -6, there's nothing left to solve for, which means you're not going to have any x-intercepts. The y-intercept, you plug 0 in for x, so I'm going to have -6 over -1, which will be +6, and that's a nice point I can plot right off the cuff. Then I need to test some points, and really once I have this first point, again, if it's a basic, simple rational function, I do know that I'm going to have a hyperbola branch here, and that's why having these asymptotes in is nice, because it gives you a feel for where the pieces of your graph will fit. So always wherever your vertical asymptote is, test the points to the left and to the right. Well, I already have this point to the left, so maybe I would test -1 and -2, and then +2 and +3. And you can certainly do as many points as you want. But if I put -2 in, and I'll just talk through these, -2 minus 1 is -3, -6 divided by -3 is 2, so -2 and 2 is a point. -1 minus 1 is -2, -6 divided by -2 is +3, so there's a point, and again I kind of knew that, but there's that nice hyperbola branch approaching both asymptotes. If I put in +2, 2 minus 1 is 1, and -6 divided by that is -6. Put in 3, 3 minus 1 is 2, -6 divided by 2 is -3. So 2 and -6, and 3 and -3, and again I can get that other hyperbola branch following the asymptotes. And then my domain is all real numbers except x cannot equal that vertical asymptote, which is 1, and my range is all real numbers except y can't equal its end behavior asymptote, which is y equals 0. Alright, the last one, kind of a special case because you have this +3. So if I disregard that +3, it's really like the last problem, except everything will be shifted up 3. So keep that in mind, and I'll tell you when that comes into play. But again, for your vertical asymptote, you solve that denominator. So x equals 2 would be my vertical asymptote, and again, I'll draw that in. My end behavior asymptote, because the degree on top is less than that of the bottom, again would be y equals 0, but now here's where it's tricky. You have to catch that everything's shifted up 3, so instead of y equals 0, if I shift everything up 3, that's really going to be an end behavior asymptote of y equals 3. So I'll toss that in. And then x-intercepts, again, technically, I solved the numerator, but this shifting +3 gets in the way kind of everything. So I'm really going to put, for my x-intercept, I'm going to put 0 in for y, because now I can subtract that 3 over. And when I multiply by x minus 2, I'm actually going to have something. So I'm going to multiply this times -3, kind of cross-multiplying. And squeezing this in, I'm going to get x equals 1. So my x-intercept will be 1, 0. The y-intercept, if I put 0 in for x, I'm going to have -1.5 plus 3, which will be 1.5. So that's, and really that gives me this hyperbola branch, so I probably don't need to test any more points, and I know the other one will be kitty corner of that. But I'll probably test a few points over here, like 3 and 4, and you could certainly do maybe -2, you know, whatever you feel like you need to test. So if I test -2, That's going to be 3 divided by -4, so -3/4 plus 3 will be 2 1/4. If I test 3, 3 minus 2 is 1, so that's going to be 3 plus 3, which is 6, and 4 minus 2 is 2, so 3 halves plus 3, so that's going to be 4.5. So -2 and then 2 1/4, 3, 6, and 4 and 4 1/2. And that's, again, enough to see those 2 hyperbola branches. And your domain is everything, all real numbers, except for the vertical asymptote, so x can't equal 2, and your range is everything except for that m behavior asymptote because it's horizontal, so y can't equal 3.